All right, so in this equation, we've got just a rearrangement of the same operations. The important thing to note here is that the fourth power, where we split into two solutions, happens in the middle instead of at the very end or at the very beginning. Let's read x turning into 7. First operation is subtracting 5. The second operation is a fourth power. And the third operation is multiplying by 3. Similar to the one that we had on the previous page. So turning 7 back into x, we're going to perform inverse operations in reverse order. The last thing that happened to the x was we multiplied by 3. So the first thing that we're going to do is divide by 3. The second thing we're going to do is undo this the fourth power with a 1/4 power. And this fourth root is where the two solutions are going to show up. Once those two solutions show up, I have to do any further operations to both of them. So when the two solutions show up, there's still a +5 to go. I'm going to have to do +5 for both of the solutions. So we're going to start with 7 and divide by 3. And we get 2.333. Then we take the 2.333 and raise it to the 1/4 power, or do a fourth root. And this is where our two solutions show up. So we have plus and minus 1.236. Now we're going to add 5, and we have to add 5 to both of our solutions. So I have to take the plus 1.236 and add 5. We get 6.236. And I also have to take the negative 1.236 and add 5. You get 3.764. So there are our two solutions, 6.236 and 3.764. The two solutions happen. The two solutions show up as soon as you invert an even exponent. Moving forward, you have to do any remaining operations to both answers. The two solutions happen as soon as you invert the even exponent. Once that happens, you have to do any remaining operations to both solutions. So when the two solutions show up, that's when you have to, moving forward, any subsequent operations have to be applied to both. Here I have the same three operations in a different order. And in this case, the first thing that we're going to be undoing is that fourth power. So that's when our two solutions will show up. So if we just, to do this problem just on our calculator, we would take the 7. First thing we would do is raise it to the 1/4 power, knowing that we have to go back and do the negative version of this. Then we'll undo the multiplying by 3 with dividing by 3, and then we'll add 5. So one of our solutions is 5.542. And then we have to do the negative fourth root. So I'll have to take a negative 7 to the 1/4 power. That's the negative 1.627. Then we'll divide that by 3, negative 0.542, and then add 5 to that to get our other solution, 4.458. So as far as what we need to write down, there's not very much, but we have to be able to read what's going on. So we can do the inverse operations in reverse order. Sometimes it helps to do the first part of the process. Sometimes we will want to make sure that we write down our plan so we don't lose track of things. Oh, I did these backwards. So now we can see why we write things down. I did these backwards. So our first one is 2.209. Then we have to do the negative version. Then we add 5 and then divide by 3, and then we get 1.124. This is a nice demonstration of why we write things down. But this first step, 7 to the 1/4 power, that's where we get the two solutions, plus a 1.626 and negative 1.627. Then we have to do both operations to both solutions. So here's an equation, 5 cosine of x cubed is equal to 2. Here's another one where we see that there is going to be more than one solution. We have a trig function, so we have got this cosine business. So this is going to produce two solutions, one in quadrant, if it's positive, it'll be in quadrant 1 and 4. If it's negative, It'll be quadrant 2 and 3. So this cosine will make two solutions, quadrant 1 and 4, or quadrant 2 and 3. Let's write down our plan, our read, and then let's write down our plan. So it's somehow we turn x into a 2. The first operation is a third power. That's not going to give us two solutions because it's an odd exponent, so that's okay. But then we did the cosine of x to the third. That's where two solutions are going to show up, and then we multiplied by 5. So to turn a 2 back into an x, first we'll divide by 5. Second, we'll do a cosine inverse, and then we'll have to do two solutions. And third, we'll do a cube root or a 1/3 power to both of the solutions that show up. So I'll start with the 2. 2 divided by 5 is a 0.4. Then I'll do a cosine inverse of 0.4. First, we'll make sure we're in radian. And then a cosine inverse of 2 divided by 5 is 0.4. And then the cosine inverse of 0.4 is 1.159. So the cosine of something is a 0.4. So we have a positive cosine. So we're going to get we want quadrant 1, and we want to put this in quadrant 4 as well. Cosine will tell us about the calculator, sorry. The calculator will tell us about quadrant 1 or quadrant 2. That's where the cosine inverse works on our calculator. Yes. The first operation I did was 2 divided by the 5, and that's the 0.4. And then to do the cosine inverse, I go second cosine. Because we're undoing things. We're solving the equation by doing inverse operations in reverse order. So if 5 cosine of x cubed is equal to 2, the first thing we did was divide both sides by 5. So we have 5 cosine of x cubed is equal to 2. So the first thing we did is divide by 5. So cosine of x cubed is equal to 0.4. Oh, okay. Then we have to get the cosine inverse. Okay. No, that's okay. It's cool. I am doing things weird and not the normal way, because the normal way is to do things to both sides of the equation. I want to try to get rid of all this writing, get rid of this writing, and just calculator stuff. I'm in radians. It's not cosine of 0.4, cosine inverse. So cosine inverse of 0.4, and you got 1 point. Oh, there you go. So this 1.159, that's the angle that we have in quadrant 1. So cosine is going to tell us about stuff in quadrant 1 and quadrant 2. We got to put this 1.159 also in quadrant 4. So I'll say 2 pi minus 1.159. That's going to be our angle in quadrant 4. .123 or 124. So now I've got angle in quadrant 1, and I've got my angle in quadrant 4, because those are the two quadrants where cosine is positive. Next, we need to raise both of these to the 1/3 power, because we've split to two solutions. So I have to take 1.159 and raise that to the 1/3 power, and also 5.124 and raise that to the 1/3 power. Now, 5.124 is the one that's sitting there, so I'll raise that to the 1/3 power. And then I'll do the cosine inverse of 0.4 to get that back and raise that to the 1/3 power. And there are our two solutions, 1.050 and 1.724. Now we'll notice that this is not an odd problem, so I can't just look in the back of the book and look up the answer. I've already checked. In the back of the book was just a blank page. So fortunately for us, we are looking at an equation. We're supposing that these are solutions to an equation. So if we want to make sure that we're right, we just have to plug them into the equation to see if they work. And here are our instructions for plugging into the equation, because we read the equation. So I want to take the 1.050, I'll raise that to the 3rd power. Then I'll find the cosine of this number. And then I'll multiply by 5. And I'll get the 2 that we expect. I'll also take the 1.724, I'll raise that to the 3rd power. Find the cosine of that answer. And then multiply that by 5. And there's the 2 again. Notice it didn't come out to a nice clean 2 because I used a rounded off number. That 1.724 has been rounded off. Any questions? How's everybody okay? This is where I like to start solving equations. Mostly because y'all weren't in my algebra class, which doesn't exist anymore. This is how I like to think about solving equations. Then there are the other parts of solving equations. If the variable appears more than one time, then we have to do different things. And the different things that we do depend on how that variable shows up. If it shows up in a quadratic equation, then we have to do quadratic equation stuff. If it shows up in a rational equation, then we have to do rational equation stuff. But all that is very specific stuff. And I want an overall plan for dealing with a variable that appears only once. I also like thinking in terms of inverse operations in reverse order because I like thinking in terms of function and inverse function. If I want to write the inverse of this function, here's all the things that I need to do. First of all, plan to have more space down here. But if I want to write the inverse of this function, I just take my x. It has to be divided by 5. And then we have to do the cosine inverse of x over 5. And then I have to take all that and raise it to the 1/3 power. So I have to do a cube root. And so there's my inverse function. I just have to write down these things as the inverse. Also, when we write down the view here, what's going on here, write down our read on the equation. That's how we can actually read the equation if we need to speak it back in words so that there's no doubt as to what we actually mean. So to read this equation, I would say 5 times the cosine of the cube of a number is equal to 2. This one is nice and straightforward because it follows the order of operations, so it's easy to say. But this one, we have 3x minus 5 to the 4th is equal to 7, which is 100% not what I just read. That's what I said, but that's not what this reads here. If I said 3x minus 5 to the 4th equals 7, that could be interpreted as 3x minus 5 to the 4th, which is 625. But that's not what I wanted to say. I could say the quantity 3x minus 5 to the 4th. But that would be the same exact thing. The quantity 3x, you don't say when that ends. However, if you read it as the 4th power of the difference between 3 times a number and 5, now I have said exactly one thing. That's this expression. No, bottom and top. The 4th power of the difference between the 3 times a number and 5. Read it bottom and top. Read it in reverse order. This one here, 3 parentheses x minus 5, close parentheses to the 4th, that's spelling it, and that's not how you communicate stuff. We don't spell space, to space, pach space, otagr, right? That's not how we communicate. So if we wanted to read this properly to make sure everybody gets the parentheses in the right order, say 3 times the 4th power of the difference between a number and 5. 3 times the 4th power of the difference between a number and 5. You read it in that order, from bottom to top, you will definitely be reading it correctly. Your communication will be clear. Your windows won't be tinted. Everything will be fine. This is how you untint your windows. So you don't have to spell at each other. Any questions? Comments? Snide remarks? Deep thoughts? All right, that's going to do it for today. That's going to do it for this week. That's going to do it for the class before spring break. So everybody have a nice spring break. I'll see you on the following Monday, and thanks for playing.